Hey boys and girls, today I want to review how to find equivalent fractions. So remember, equivalent means equal. It means your value's not going to change, but your image might change. So if we're starting here with the value of 1/2, I could model that in a rectangle or anything else where I have two pieces reflected by my denominator in my whole, but I only have one of those pieces shaded. In return, I could then model and switch that into 4 pieces. If I switched it into 4 pieces, how many of these would need to be shaded to create a fraction of 1/2? The answer that you should have gotten or thought about would be 2. So an equivalent fraction of 1/2 is 2/4. I could also change that up again. I could do 4ths, and notice how here I'm modeling it in a different way. So I still have a denominator of 4, but if I wanted to illustrate that I only have half out of those 4 wholes, I could shade in 2 of the longer pieces. However, that still represents half of my whole. So these are all equivalent fractions. You could continue, and you could be splitting your whole into several different parts. In this particular example, I've split it into 6 parts. In order to create an equivalent fraction of 1/2, I would need to shade in 3 out of the total of 6. So my go-to for creating an equivalent fraction is picking a denominator that's an even number. So for example, 10. And I think, okay, what is half of 10? Half of 10 is 5. Therefore, 5/10 is going to be equal to 1/2. If I wanted to prove it, I could. 1, 2, 3, 4, 5, 10 pieces. To create 1/2, I would get 5 out of the 10 pieces there in my model. I want you to go ahead and try one on your own. Pick a denominator we have not used yet to create an equivalent fraction to 1/2. So we did a lot of work with creating equivalent fractions that were equal to 1/2. But you can do the same thing even if your fraction that you're given isn't 1/2. So, for example, if I had the fraction of 1/3, here I have my 3 pieces as reflected by my denominator, but I only have one of those 3 pieces. If I was going to make an equivalent fraction, that would mean I'd be changing my denominator. So I could do that by marking this whole in half again. So now I have 1, 2, 3, 4, 5, 6 pieces. To have it equal 1/3, I would need 2 out of those 6 pieces. When I'm looking at these fractions, I see something that I think could help me make equivalent fractions in the future. I notice that I first changed my denominator to 6. Well, going from 3 to 6, I can multiply it by a factor of 2, which is exactly what I did. I split it into 2 pieces. When I multiply my numerator by that same factor, I get 1 times 2, which is 2, which is exactly what I got when I modeled making equivalent fractions. So I'm going to try using that strategy now. If I'm starting off with a fraction of 1/3, maybe I want to multiply it by a factor of 3. So my new equivalent fraction will have a denominator of 9. I need to multiply my numerator by that exact same factor. 1 times 3 equals 3. So 3/9 is equal to 1/3. Why does that work? Because when you multiply it by a common factor, it creates an equivalent fraction. Let's try that one more time. Given the fraction of 1/3, now I want to multiply it by a factor of 5. So now my whole is split into 15 pieces, but I still want 1/3 of those 15 pieces. So I can multiply my numerator by that common factor which 1 times 5 is 5. Therefore, 5/15 is equivalent to 1/3. I want to see if you can do that on your own for the equivalent fractions of 1/4 over on the right side of your paper. If you have any questions, post them on Google Classroom and I can answer them for you.